Hi everyone, and welcome to episode 1 of the Spark podcast. My name is Jack, I'll be your host, and today we will talk about learning. Because it's the first episode, I'd just like to talk a bit about what Spark is, and why it's a podcast. I'm the kind of person who loves to learn things and will always talk about them, regardless of if you're interested or not. So this is my opportunity to give people a pause button or a mute button on me, because sometimes I get a bit carried away with what I learn because I just get enthusiastic about it and I just ramble. So this is my outlet to ramble on, and if people want to listen, they can listen. If they don't, they hit the mute or they listen to the next episode. I'm going to try to touch on a few topics that I find interesting that wouldn't be talked about in everyday life. I've just got loads of ideas I want to talk about, and the first point I think I need to start from is learning in itself. Why we're learning, why we're curious, why we feel good about learning, and why we feel the need to share what we've learned with other people. It's something that I've always been interested in. I believe I've only kind of been aware of my interest in it recently enough. So this is my outlet to talk about things in a little room to myself with no one on the other side. So I may go a little bit crazy. I may ramble on a bit too much, but I think that's the kind of essence of this. Is it's a kind of a laid back, me just talking and teaching you something, and hopefully teaching myself along the way. It's also why I came up with the name Spark is I wanted to be a spark of curiosity in whoever's listening. So I'm not going to go too in-depth with a lot of things. I'm kind of aiming for like a 10 to 30 minute podcast. It may be an hour at some topics, depending on what's going on. Now, I assume episode 1 is going to be quite short. It's just kind of an introduction to this and a bit of learning. So hopefully we'll learn a bit as we go through this, and it'll spark a bit of curiosity in people who are listening, because I think that everyone can learn with access to the internet nowadays. It's just instantaneous. If you want to learn something, you can in less than 30 seconds. It's really amazing. So the way I did it was, the way I researched things, I suppose we'll talk about, is I asked myself questions. And I wanted to learn about learning. So, the first question that occurred to me is why we learn, and a part of learning is being curious. So I tried to find out, why are humans so curious? Why are we so curious? And I came across a lovely article, a beautifully written piece really, that I might butcher, by Tom Stafford. He wrote it for BBC.com in 2012, and I can't remember if it was the title of it or the quote that kind of dragged me to it, but he said that evolution made us the ultimate learning machines, and the ultimate learning machines need to be oiled by curiosity, which pretty much dragged me through the whole thing, and it made me read all of it. But he goes into why we look at things that are not immediately obvious that are useful to us. You know, we'll read news about people we don't know and learn things that we'll never use, because we just like to know the answer to questions. Like if someone comes up to you and asks an obscure question, it's nice to know the answer. It feels good. It makes you feel smart. But we'll learn things that we have no use for in our everyday life. It's like, even if there's no benefit at all that we can see immediately, we'll just go and learn about it. So he kind of goes into the evolutionary part of it, and why would evolution give us some sort of thing in our brain that makes us learn about things that aren't important to us? Shouldn't it have made us more focused and more desperate to learn things that are immediately useful to us, like where our next meal's coming from, who we should mate with, what we should protect, all these like basic elements of survival? Shouldn't we have focused on these? But there is a part of evolution in humans anyway, known as neoteny. I may be mispronouncing that. It's Neoteney. No, Neoteny. I really can't read my own writing sometimes. It's neoteny. It is the retention of juvenile characteristics. It's what sets us apart from other mammals. It makes us more childlike. So we have kind of a bigger head to body ratio, unlike most other mammals. It also gives us lifelong playfulness and curiosity. So it basically makes us enjoy life and have fun and just wonder what's going on over there. We just wander off into the forest, see those berries, they may be good, and we eat those berries and someone dies, but then we know those berries are poisonous. Mightn't be good for the guy who died, but we know. And there was curiosity that led us into the forest to eat those berries, and now we have a bit of knowledge. Wasn't immediately useful at the time, but for generations to come, we now know about those berries. Neoteny really is a shortcut taken by evolution. It made us physically weaker. For example, a gorilla would absolutely destroy any human. If you ever try to punch a gorilla, you're going to have a bad time. Just look at those things; they're fucking enormous. Even a chimpanzee that looks relatively quite small could rip you apart pretty easily. So we gave up a lot of our physical strength for our brain sizes and our curiosity, which may seem like a bad play, but look where we are and look where the monkeys are. I think we're a bit ahead of them. Neoteny has increased our capacity to learn, and it gave us a deep sense of closeness and attachment to each other. So, like I said with the berries, if one guy say if Greg dies, you're going to tell your buddies that Greg died when he ate those berries. So we'll all learn, and we'll all collectively know, avoid the berries. So it gave us that curiosity to learn about things, and also to spread the information, which has caused technological explosions and brought us into what is essentially the future, which is right now. It's nuts. It's allowed us to create things to benefit each other long into adulthood. It's the juvenile characteristics carry on into being over 18 or reaching full puberty, getting into their older ages, and we're still creating things just because of this neoteny. It's just a part of evolution that's exclusive to humans. Curiosity also gives us an exploration bonus. Things that may be useless to know now that we've learned by accident, such as the berries, may be extremely useful to know tomorrow. It would be great to know in advance what might be useful to know, but in the future, sorry, I'm getting mixed up in my notes here. What the fuck am I saying? Oh, yeah, it would be great to know in advance what might be useful to know in the future, but an ever-changing world is unpredictable. So we've only got curiosity. That's our combatant to not being able to know the future, is we just kind of go look at things and figure it out from there. Curiosity has led us to massive knowledge increases. I think there's two quotes really that sum it up. One is from Kurt Vonnegut. He said, "We are here on Earth to fart around. Don't let anybody tell you any different." And the other one is from Adam Savage, and it's one of my favourite quotes of all time. He says, "Remember, kids, the only difference between screwing around and science is writing it down." That is it. So from there, that led me on to what is actually worth knowing. What is a fact? There are a lot of things out there that can be old wisdom, but not necessarily true. And the only way that we know, well, I suppose if you look at it philosophically, there is nothing that is actually true. but there are things that we have learned over time and we all accept as universal truths. The way that we identify these is we use the scientific method. It's a method that has been used since the 17th century. Now, that's according to Wikipedia, so I don't know. That's the only way. That's the only source I could find that said that it was used. So that it was started at such a date, and Wikipedia says the 17th century. So that's all what I'm going to go off. But the term scientific method came into use really with the public in the 20th century. So to get a kind of idea of what the scientific method is, I went to Khan Academy, and they've kind of laid it out into a 6-step process. Step 1 is you make an observation. Step 2 is you ask a question. Step 3, you construct a hypothesis. Step 4, you make a prediction. Step 5, you carry out some tests. And step 6 is you iterate. For example, they had a nice toaster example. Say there was a problem with your toaster. It's not toasting. So first you make an observation. Part number one, make an observation. The toaster won't work. It won't toast the toast. You don't toast, you toast bread. It won't toast the bread. Step number 2, you ask a question. You wonder, why won't it toast? Why won't it turn the bread into toast? Step number 3, you create a hypothesis. And this is essentially guessing, in layman's speak. You say, for example, you say, maybe the socket's not working. So that's your hypothesis. That's what you're testing for. You're testing the socket. 4, you make a prediction. And say, for example, your prediction is, if I try a different socket, the toaster will work. So that's your prediction based on your hypothesis. And if you want to test it, you have to carry out tests. So you test your prediction based on your hypothesis. And the way to test that is you plug it into the other socket. Then when you plug it in, you'll get one of 2 results. It'll either work, and your hypothesis that the socket was broken or not working is supported, or it won't work, and your hypothesis is not supported. Based on either of these results, you iterate different ways. So if your hypothesis was supported and that the new socket was working, the old socket was broken. So your iteration on that is what's wrong with the socket. So that's a whole other scientific method. You go through the cycle again. You go through the 6 steps. So you start with the socket as your observation, and your question is, why isn't it working? I'm not going to go through that because it's just too much. The other possibility is that the toaster doesn't work in the new socket, so your hypothesis is not supported, and you iterate again. You start back with what is wrong with the toaster. You try something else. Maybe it's the wiring inside, and you go back to a different hypothesis. You say the wiring isn't working, it's not connected in some way, whatever. But we go through that, and that's how we learn things. That's how we make observations. It's the same for big scientific experiments, like if we want to know if this certain drug works on a disease such as cancer or the flu or anything at all. We go through these steps. They're universal, they're easy to follow, and anyone who's ever done science has come across them in one shape or another. You don't even have to do science. I use it in work all the time. I'm a biomedical engineer by trade, and I fix machines. If I get to a machine and it's not turning on, I ask myself, I make the observation, it's not turning on. I ask myself, why is it not turning on? And I construct the hypothesis of, it's probably not plugged in. Then I make a prediction, if I plug it in, it'll work. plug it in, that's my test done, it works fine, then it's good to go. You're using the scientific method every day, even if you're not aware of it. And in most cases, it's a cycle. So if you don't get it done in one go, maybe I plug in that machine and it still doesn't work, then I gotta try something else. So I just keep going through the cycle until it works. And it's the same for coming up with new devices, why they won't work, if they would work. You keep trying different things, keep coming up with different hypotheses. Hypotheses? Is that plural for hypothesis? Hypotheses. I'm going to coin that new word, is hypotheses. And that's how we learn things. That's how we know what facts are. If things aren't supported, things can't be replicated, then we don't know they're facts. That's another thing, actually, is if you do come up with something new, it's got to be peer reviewed. That would mean getting it published in a journal and talked about by super smart people like scientists or engineers or people in charge of massive corporations like NASA and all that. People who've done that stuff before and kind of know what they're talking about, and everyone agrees that makes sense. There's no exact science to science, really. It's just we all kind of go, yeah, that worked, and we move on. We use it for other things, and if it works for other things, great. If it doesn't, that's kind of great too, we know. So, they're facts. They're what we should know. So then I went into a bit more physical study, and, well, it's a bit of chemistry too, and biology. I suppose everything is. But I went to look into what happens to our brain physically when we learn, and I don't know if this is like an expert way to go about it, but I found an article by a high school student which pretty much nails exactly what I was going for. It's a very light intro to what's actually going on, rather than going in depth and learning about all the different synapses and how they work. Well, we do that, but not very in depth. It's a synapse. Just trust me, it works like that. So I found a very nice, I don't know if it was a report or like part of her education, but she did it very well. It's Emma McMullen. She she made a video really for chemistryislife.com. She called it The Chemistry of Learning, which is pretty much exactly what I was looking for, so it was great when I found it. She says that learning is the process of filing information away and being able to retrieve it again, which, makes sense. You learn something, you put it in your brain, save it, hopefully, and you use it later. My main problem is I forget everything I learn. So this is another reason why I'm doing this podcast. It's just so I can look back over the archives of stuff I've learned. And I also have it written out in my notes. She says that new neural connections form all the time and are strengthened by practice, repetition, or memorization. These kind of stuff you would know from learning or studying if you've ever gone to school, which I hope you have. You should go to school. If you haven't, go back. The brain is made up of neurons. They're basically nerve cells. A lot of people call them brain cells. They're the things that people say you lose when you go drinking. I haven't found any reasons to believe that's true. But again, I haven't looked for it. Maybe that's an episode that I could think of. That's an episode that I could do. What happens to your brain when you're drinking? But anyway, we'll continue on. We're trying to find out what happens to your brain when you're learning right now. Neurons, your brain cells, communicate by synapse. A synapse is a space between the morons? It's space between morons. Fucking hell. Neurons communicate by synapse. A synapse is the space between neurons used to send information from one cell to another. The information travels at up to 320 kilometers per hour, so it's pretty quick once you get smart at something. The more you know something, the more readily available it is, the faster it gets. Neurotransmitters are chemicals that trigger electrical impulses in the brain. For example, serotonin affects your mood and appetite. Norepinephrine regulates your stress. And acetylcholine controls muscle contractions. So we kind of know all the parts of the brain now. Well, I went over it pretty quickly, but, you're not really learning a lot here. You should know that neurons are in your brain and synapses are what are traveling from neuron to neuron. It's a little gap. It's like an electrical impulses travel over them. These electrical impulses are neurotransmitters like serotonin, norepinephrine, and acetylcholine. Right? Caught up? We'll go on. How learning works is you create new information in your brain, and that's known as neurogenesis. When you want to retrieve information later, an electrical impulse is sent through your neurons, starting a chain reaction. This causes a neurotransmitter to be released and diffused across a synapse. The receptor so a transmitter goes from one neuron across the synapse to the other, and the receptor on the other side of the synapse receives this neurotransmitter and creates another electrical impulse. So if you imagine it's a little explosion across each one. Now, it's not exactly an explosion. That's just the way I like to think about it. It's a little spark. Podcast. Branding. It's a little spark that goes from each cell in a chain reaction, just go the whole way down through your brain to where the information is kept. And this repeats until your brain sends the message to your synapses to stop doing that. Where learning actually begins, memorizing something or creating something or just hitting a home run or kicking a rugby ball between the uprights for the first time, you learned how to do that, how to successfully do that. An exchange happens all over your brain. At first it goes slowly and the impulses stop and start more frequently because you don't really know what to do next. But after a lot of practice, the synapses fire more quickly and the information becomes more readily available. This is to the point where you feel like you know something. You've officially learned. So that's basically chemistry, biology, and physics telling you to practice. There's no substitute for practice and hard work. The more you do something, the better you get at it. And I think that the more you learn, the better it is for your brain. The better for your brain, the better for your body, the better for your life. You will just feel better about learning if you learn. So I went into why adult education is such a popular thing, and well, it's not a very popular thing. I think it should be more popular, but it's something that everyone knows they should do. They should learn more. They should be smarter. So I went to CCSU Adult Education, and I found an article by Krista Sterling about adult education and why we should learn. She says that every time we learn something new, our brains form new connections and make existing neural pathways stronger or weaker. So if we learn something new that makes something redundant, we'll keep the new thing, and the redundant thing, that pathway that we made before, will become weaker, and a new path will become stronger because we'll use it more. This is kind of referred to as the plasticity of your brain. And it's a physical thing. I'm just going to take a drink of water actually because I'm getting a bit parched. So man, I've been talking for like 25 minutes now. It can get tiring. So we're talking about the plasticity of your brain, and our brains keep changing physically until we die. The more you learn, the more plastic your brain will be. The more it will change, the healthier it will be. Everything we learn starts as short-term memory. Some of it transfers to long-term memory storage in our brain, and sleep is very important for this. It's the point of our day where information transfers from short-term memory to long-term memory. That's why when you go without sleep for a couple of days, you can feel a little woozy, and you start forgetting very basic things. Like, I know I've gone without sleep and I've left my keys everywhere. Go out the door, lock the door behind me, and then now I'm tired and angry. And I'm angry because I'm tired. That's why you get cranky, because you keep forgetting little things and you get angry with yourself. So get your sleep while you're learning. It'll help. Learning is often exciting for the learner, so it's good for you. It makes you feel good. Novel experiences cause a release of dopamine, which is the happy chemical, which comes out when you take ecstasy, which makes learning exciting and makes you want to repeat the experience. So the more you learn new things that you didn't know before, a little part of your brain goes, that was good. You enjoyed that. Good on you. Do it again. Keep doing it. Keep learning more things. Myelin is the chemical. I'm jumping all over the place here. But yeah, dopamine comes out when you learn new things, helps you feel good about it. There's also a chemical that makes signals in our neurons move a little bit faster. This goes back to the 320 kilometers per hour speed I was talking about before. It's called myelin. It allows us to access information stored in our long-term memory a bit faster. Myelin works especially well when a new experience is repeated multiple times, and this is getting back to the whole practice thing. So we got to keep doing it. I know it can be frustrating, or it can be annoying if you're not getting something straight away, but trust me on this. The more you use your brain, the better it'll get. And the better your brain gets, the better your body will feel. It's a whole system. Your brain's part of your body. I keep saying it like it's a different part, but it's not. It's part of it. It's part of your system. So if you have a healthy brain, you'll have a healthy mind, you'll have a healthy body. That's my opinion anyway. And contrary to this, you may have an unhealthy brain. There are very bad side effects from not learning, from being stagnant and not having a curiosity to go out and learn things. Some British research, I'm not sure who did it, it just says British research shows that boredom can be dangerous to your health. People who participated in this study of, I don't know if it was a survey now or what, but it kind of goes with what you think would, excuse me, it kind of goes with what you think would happen if you weren't learning. People who reported being bored over a long period of time had heart disease rates more than twice as high as those who did not report any boredom. Not learning new things or having no new experiences will slow your brain down and make it less responsive. So that goes with the plasticity of your brain. So the more you use it, the more plastic it gets, the more readily available myelin is made. And the more myelin in your brain, the faster you can access long-term memory. And if we can access long-term memory even more, we can learn things in short-term memory. Adult learning is good for your health and has been shown to slow the onset and progression of Alzheimer's and dementia. Two things I am deathly terrified of. So, well, it's not something that I'd like for myself. And it also prevents the general slowing of your mind and mental faculties. I've always wanted to be the smartest person in the room. I very rarely am, but, part of learning is part of keeping your mental faculties ticking over. Just keep going, man. And the conclusion of all that study is that learning is good and not learning is bad. So, what I can say to you, people listening, is go out, pick something you're interested in, learn a bit more about it. Sometimes I find it's refreshing to like pick a random subject, go onto Wikipedia, click random article, start from Wikipedia and learn a bit more there. If you go down to the bottom of a Wikipedia article, it'll have the sources and the bibliography. That's a good place to start if you want to learn a bit more about that. But I like to go to random articles about God knows what, people I've never heard of before that I have no interest in, and just learn a bit about them. Just make those new neuron connections in my brain, stimulate some myelin growth, learn a bit more, and do new things. And that is it for episode 1. I want to thank you all for listening. Remember to learn and stay hydrated. Bye-bye. So that episode went on a bit longer than I thought it would. My power to ramble goes on much more than I thought. But I want to thank everyone for listening. And I'm going to come back with a new episode. I don't know what the next topic is going to be yet, but I'm going to do a bit of research now, come up with more. I don't know when the new one's coming out. I'm thinking of doing these every week, but my life is very busy. I don't really know if that's possible. I'd like it to be possible, but I don't know. So if you like this episode, get at me at Twitter. It's at Podcast Spark, PodcastSpark, and let me know how you got on with it, how much you liked it. If you didn't like it, let me know. If there's something you want me to talk about and learn more, if you want to learn more about something and you want me to talk about it, let me know through there. Thanks for listening, and I'll see you guys in the next episode.